Good evening. Today we are going to solve the problem that is of axial load plus uniaxial moment, which we required for our term work. So we have this problem. I have continued with gantry girder. I have reaction of gantry girder 341.90, and this reaction is due to dead load plus live load, because dead load plus live load will develop compression and dead load plus wind load will develop tension. That will be in the opposite direction of the reaction due to gantry girder, and therefore we have to add dead load plus live load reaction. So total reaction is 363.56 kilonewton, and bending moment, which we have used already for gantry girder, eccentric connection of gantry girder, 102.51 kilonewton meter. So we have to design it for this axial load 363.56, and for bending moment 102.51 kilonewton meter. So now we will start with this. So now let us moment is larger one. So I will go for higher section, that is ISHB 450. And that is at 925 Newton per meter. So I will consider this section. So now if we will go to clause number 9.3, page number 30, sorry, page number 70, then we have N by ND plus Mz by Mdz plus My by Mdy. This value should be less than or equal to 1. Now, and this we have value 363.56, that is external load or given load. Mdz, we have this value 102.51 kilonewton meter. Then we have Nd. Now, if we will go to this, then they have given this as AgFy upon gamma mo. And Mdz, we have beta b, Zp, Fbd. And we know Fbd, we have already seen how to calculate it. And this is because we are going to consider beam as laterally unsupported. And as we have uniaxial bending, so this term will not be there. So we have only N by Nd plus Mz by Mdz less than or equal to 1. So now as bending moment is large one, so I have considered ISHB 450. If your value is lesser, you can go to 400 or 350 likewise. So now first I will find Mdz value. So we have properties of the section. Properties. So we have A11800 mm square, TF 13.7 millimeter, ZP 2030.9 into 10 raised to 3 millimeter cube, RYY 50.8 millimeters, BF 250 millimeters, TW 11.3. Now we have to first find the classification of section. So we have B upon TF, that is equal to 250 by 2 upon TF. We have 13.7, and this value comes 9.12, which is less than 10.5. So flange is compact. Flange is compact. Then we have d by tw. So d we have 450 minus 2 into 13.7 divided by 11.3, and this comes 37.4 less than 84, considering epsilon 1. So wave is plastic. Therefore, section is compact. Section is compact, and beta B therefore is 1. Therefore, beta B is 1. Now we have to use clause number 9.3.1. Clause number 9.3.1.1. This is for plastic and compact. And if it is semi-compact, then we have 9.3.1.3. So now in this we have actually same. So now we will go with MDZ, and for this we have to find value of KL upon RYY. So now we have this value. Column we have considered 12 meters, and value of RYY we have 50.8. So this value comes 236.88. Then we have HF upon TF. So HF we have 450 minus 2 into 13.7 divided by value of TF is 13.7, and this value comes 31.85. Now if we will go with these values, so we have KL upon RYY, HF upon TF. So we have 230, 240, and HF upon TF we have 30 and 35. Now if we will find these values from table 14, then we have 81.5, then 72.9, 77.2, and 69. And if you calculate this value, so we will get from this FCRB. Now I will not calculate this. You can go through this. We have 75.74 Newton per mm square. And knowing this value of FCRB, table 13A, we have FCRB and FBD. So FCRB we have 70, 80, and from this we have FBD 63.6, and then 56.8, and from this we will get FBD. Now these calculations you can do. I have taken directly Newton per mm square. Now from this I can find value of MDZ. So we have MDZ equal to beta B ZP into FBD. Now we have beta B 1. Then we have ZP 2030.9 into 10 raised to 3. And we have FBD value 60.7. And from this we will get this value of MDZ, that is 123.27 kilonewton meter. So into 10 raised to 6 Newton millimeter. So now as this value is greater than 102.51, and therefore we can go to the next part, that is ND value. And we have ND that is equal to AG Fy upon gamma m. This value always we will get larger one. AG we have 11800, Fy we have 250, and gamma mo we have 1.1. And from this we will get this value 2681.82 into 10 raised to 3 Newton. So now we have MDZ that is 123.27 and ND 2681.82 kilonewton. And then we will put it in the formula N by ND plus MZ by MDZ, and then we have value of N 363.56, ND we have 2681.82 plus MZ we have 102.51, MDZ we have 123.27, and this value comes 0.97, which is less than 1, and therefore provide ISHB 450 at 925 Newton per meter as a column. And so this is your design of column. So now we will stop here only. So remaining part we will see in the next lecture. So thank you.